Number 3 says cos of x is equal to sine of 150 degrees minus x. I'm going to start by making this cos of x, well, leaving the cos of x as is, but turning this sine of that into cos of 90 minus 150 degrees minus x. That means that x is going to equal 90 degrees minus 150 degrees plus x plus k times 360, where k is an element of integers. But there's only one possible answer. The other possible answer, where else is cos positive? Cos is positive in the fourth quadrant, so that will be 360 degrees minus 90 degrees minus 150 degrees plus x plus k times 360, k element of integers. This is going to be x is equal to 90 degrees minus 150 degrees plus x. Take the plus x across, it becomes x minus x is 0. So for here, x could be anything. X is an element of reals, or rather, for this one, we're going to say that there's no solution. Because we've got x, when it comes across, it becomes negative x, and a negative x minus x is 0, so the x's are basically cancelling with each other. That's only for that one though. There's also this solution here, which is going to become 360 degrees minus 90 degrees plus 150 degrees minus x plus k times 360. Minus x across makes that 2x is equal to 360 degrees minus 90 is going to give us 270 degrees. 270 degrees plus 150 is going to give me 420 degrees plus k times 360, where k is an element of integers. If 2x is equal to that, that means that x is equal to 210 degrees plus k times 360, again k element of integers. So there's only one real solution in this case as opposed to two. The last one I gave you to do read 6 sine squared x plus 3 sine x is equal to 3. I'm going to start by making this 6 sine squared x plus 3 sine x minus 3 is equal to 0. This does look difficult. Look at this here. 6k squared plus 3k minus 3 is equal to 0. Now if I factorize this, 6 times 3 is 18. Are there factors of 18 that can give us positive 3? Yes, they are. We need to get to positive 6k minus 3k will give us plus 3k minus 3, 6k times k, 6k squared. That means that 6k minus 3 is equal to 0, or k is equal to negative 1. That this one here means that k is equal to negative 3 across becomes positive 3 over 6, which is 3 over 6, which is the same as 1 over 2. So k is either equal to 1 over 2 or k is equal to negative 1. But remember that k was sine of x. So this means that either sine of x is equal to a half, or sine of x is equal to -1. If I solve for sine of x being equal to 1/2, it means that x is equal to 30 degrees plus k times 360, where k is an element of integers, or x is equal to 150 degrees. Remember, second quadrant, 180 minus our reference angle. 150 degrees plus k times 360 degrees, all when k is an element of integers. But that's only two of the possible solutions. The other possible solution is when sine of x is equal to -1. That means that x is going to fall in either the third or fourth quadrant. So that means that x is either equal to 180 degrees plus, now second function sine of 1 is 90 degrees, so it's either going to equal 180 plus 90, which is 270 degrees, plus k times 360 degrees, or it's going to equal 360 minus 90 degrees, which by the way is also equal to 270, so we only need to write this one solution in. With k being an element of integers, that means that we've got 1, 2, 3 possible solutions. X could be 30 degrees plus k times 360, or 150 degrees plus k times 360, or 270 degrees plus k times 360. And that brings us to the end of the fifth trigonometric tutorial. Please note that this is an extremely important section in trigonometry. You do need to understand why we use the general solution and how we use it. It is also very important for the next section, titled the trigonometric graph. Before you move on to that though, I want you to have a go at the exercise that I left for you in the workbook.